Okay, Hannah Gunko, you owe me big time. I'm tired. Picking string beans, Sanford and Jerome work on a farm. Okay, so this is how you can pay me back. You can pay me back by getting a good grade on this test. Study these things, okay? Picking string beans, Sanford and Jerome work on a farm near Oklahoma. Or, if you don't get a good grade on this test, you're going to end up picking string beans for a living, okay? There we go. I'm so clever. They work on a farm near Oklahoma City, Oklahoma. Sanford can pick a basket of string beans in 40 minutes, while Jerome can do the same task in 30 minutes. How long will it take them to pick a basket of string beans together? All of these word problems are going to be rate times time equals distance, basically. Rate times time. And so it doesn't quite apply to this, but it's basically the same exact thing. Rate. What is the rate that they're picking a basket? Well, in 1/40th of a minute, this guy he picks 1/40th of a basket in a minute. 1/40th of a basket in a minute. Get it? 1/40th of a basket per minute, because it takes him 40 minutes to pick a full basket. So he picks 1/40th of a basket in a minute. So if he works for so many minutes, and this other dude works, right? He picks 1/30th of a basket in a minute. That's his rate. Rate times time. Rate times the number of minutes that he works is going to equal one basket, right? Rate times the number of minutes is going to equal one basket. Or how long will it take them to pick a basket? Their rate times the number of minutes they work, and how long will it take them to pick a basket, to pick one basket? There we go. Rate times time plus his rate times the same time is equal to one basket. How long is it going to take him to do that? Okay, so then you just have to solve it. That's the hardest part right here, okay? And there's going to be a problem like this, where it takes them and they have to do it. Well, they can do 1/40th of the job, okay, or however long it takes them, however long it takes them. And that's the rate of the job per minute. So anyway, this is 1/40th times m is m over 40 plus m over 30 is equal to 1. If you're going to add these fractions, you need the common denominator. Common denominator is 1200. Well, this one, let's go 30 over 30. We're going to multiply this, and we're going to multiply this one by 40 over 40, right? So you have 30m plus 40m all over 1200. 30 times 40 is 1200 is equal to 1. So multiply both sides by 1200, and you get 30m plus 40m, which is 70m, is equal to 1200. Divide by 70, divide by 70. M is equal to, let's see, 1200 divided by 70. That's exactly, 17.14 minutes. And just to prove it to you, 1200 divided by 70 is equal to 17.14 minutes. Dang it, I closed that. Open it again. There it is. Okay, 17.14 minutes. Paul Webster's motorboat then can travel 15 miles per hour in still water. Traveling with the current of the river, the boat can travel 20 miles. Rate times time is equal to distance, right? You can 20 miles in the same time it takes to go 10 miles against the current. Find the current. Rate, okay, so if he's going with the current, rate is his 15 miles an hour plus, I'm going to call it the current, plus the current, that's the rate, multiplied by the time is equal to the distance of 20 miles. Okay, so since they say in the same time, let's solve this for t. We can just divide both sides by 15 plus c, 15 plus c, so you get t is equal to 20 over 15 plus c. This is with the current, okay? Against the current, 15, we're gonna subtract the current, that's his rate, multiply that time, and how far does he go? He goes 10 miles, right? 10 miles is equal to 10. And we'll solve this one for t. Just divide both sides by 15 minus c. 15 minus c, these cancel. So our time is equal to 10 divided by 15 minus c. Well, okay, it's the same time, right? This is the same time, so we can just set these things equal to each other, since they're both equal to t, and solve for the c. So we have 20 divided by 15 plus c. That's the same as 10 divided by 15 minus c. And then all we have to do is solve for c. How in the world do we do that? Well, let's cross multiply. When you have two ratios, the cross multiples are equal to each other. Or you can times both sides by 15 minus c and 15 plus c. But anyway, the cross multiples, the diagonals multiplied, are equal to each other. Let's just do that. 20 outside of 15 minus c is equal to 10 times 15 plus c. 20 times 15, 10 times 15 is 150, so that's 300. Minus 20c is equal to 150 plus 10c. Let's add 20c to both sides, keep the variable positive. We'll subtract 150 from both sides. So we have 150 is equal to 30c divided by 30 divided by 30. And son of a gun, the river current is equal to 150 divided by 30 is 5 miles an hour. Look at that. Sweet. We got it. Let's take 84. Whew. W is directly proportional to the square of L. Okay, direct proportions, I think it's like A is equal to K times B. Inverse proportions is something like A is equal to K over B. For this is some constant. K is some constant, right? Well, let's set this thing up. W is direct. This is direct. So direct means when one gets bigger, the other one gets bigger. So this would be direct. This would be inverse. Okay. W is directly proportional, so we can say W is equal to some K times the square of L times L squared. And W is inversely proportional to A. If W equals 4 when L equals 2, so this one, let's change colors. So this one, when if W equals 4, 4 is equal to some constant when L is equal to 2 times 2 squared. Okay, this is the direct proportion setup. And A equals 10, so 4, W is going to equal to 4 is equal to some constant divided by 10. So in this case, the constant for the direct proportion, the constant is 2 times 2 is 4, divide both sides by 4, that's 1. So K is going to equal 1 right here, and K, the constant, is going to equal 40 right there. So for the inverse, and we shouldn't use the same letter because they're two different constants, two different equations. So it says find W when L equals 5. So if L equals 5, K is 1, we know. So W is equal to 1 times 5 squared, Well, 1 times 5 squared is 25 times 1, or 25. So W equals 25 in this case. And how about this other case? And A is 20. Well, in this case, the constant is 40, right? So W is equal to the constant of 40 divided by what? 20? A is 20, and that equals 2. So 25 and 2, and that checks out with our answer. Number 89. Inversely proportional. Time is equal to some constant divided by the temperature of the, I'll just say the temperature, capital T. Okay, so let's find out what the constant is. If it takes an ice cube 1.7 minutes, time is 1.7 minutes, to melt, so some constant divided in 70 degrees water, well, our K is equal to 70 times 1.7. 70 times 1.7. That is equal to 119. K is equal to 119. The constant of variation, I guess, would be what this is called in this case. So, how long will it take an ice cube of the same size to melt in 50 degrees water? Well, how long? So we're trying to find the time. And the constant is 119 divided by 50 degrees of water. So our time is 119 divided by 50. And that's equal to 2.38 minutes. And I like it because the answer key likes it. And so, are we done? We are done. 89. All right, Hannah. Go forth and conquer. I'm praying for you, and I love you.